questions from the audience, including the committee members, and then after that it will be a closed session. So if there are any questions from anybody, including the committee. Yes, please go ahead.
I have a question. During the model reconciliation process, you mentioned that we couldn't use the HMM directly because sometimes it's not even feasible.
Right.
Right. So in your work, do you have a pre-processing part to analyze if the HMM solution is feasible or not?
Well, it depends on what the target is. Right? So if you're making plans, then you can try to. So if you're given a planning problem, you can see if that's feasible or not. But still, the target is to make a plan that will work for you. So you can, even if it's not feasible, there has to be some way of using that to guide your decision-making process.
Yes.
So in that case, there is no. So if the plan is not feasible, there is no hope of making an explicable plan. But you can still try to be as close as possible.
So my question is, essentially, if the HMM plan is already feasible, because you're doing like a model-based searching, you
Right.
find a criteria, and your searching process will definitely stop after you meet that
Right.
criteria. So what I'm asking is that if the HMM model is indeed feasible, should the ultimate result be the HMM model itself, but instead it's a less optimal solution defined by your searching criteria?
Yeah. So if it's feasible, there is an explicable plan, but it might be too far from what you actually can do. So when it's feasible, doesn't mean that it's any reasonable cost range. So it might be causing too much cost. So that's a decision that the agent has to make. So am I going to have a huge penalty due to explicability, or do I not have that much penalty but make explanations instead? But yes, so if it's feasible in the mental model, then there is an explicable plan. If it's not feasible, then there is no explicable plan. So you have to explain at some point. Other than answer it.
Other questions? Yes, please go ahead.
So your general assumption might be that there's a closed world in which you operate, and if something is feasible, is understandable, and there are points of opportunity where you could interact and collaborate.
Right.
If something changes, and maybe the human can update that, would that be a scenario that you could
Yeah,
consider?
so the assumption in the first work was that the state space is shared, so they know the variables that we are talking about. The human knows the variables. In some follow-up work that Sarath did, he relaxed the assumption saying that the human may not know about parts of the environment. So it's like the human is at a different level of abstraction. And how do you explain in those cases? And then we also looked at, in the decision support case, we looked at cases where the human can come back and say, I do not understand this, or I do not agree with this. And then the robot has to update this model. So it's not a single step where you provide the explanation and it's over. The human come back and say, these parts, I don't agree with this part. So the robot can also get to reconcile this model. So it's a post-fail process.
Other questions? Please go ahead.
So in the examples that you've given, there is no uncertainty in either the human's model or the robot's model. So if it were the case, say, that the humans didn't know whether there was rubble in a particular location or not, or perhaps the robot didn't know, I'm curious as to what you think how do you think that impacts the nature of the explanations, decisions about explicability, so forth.
So, okay, so there might be incorrect estimations and there may be incomplete estimations. So we looked at this idea of having an uncertain model of the human. So we don't know the exact mental model, but we have possible conditions. So it's the same as in the model-like planning case. They talk about the human model may or may not have these conditions. And so what that gives us is a set of possible human models to consider. And we looked at, so in Iger's paper with this year, we looked at this idea of conformant and contingent explanations, where you try to provide an explanation that's valid in all possible models, or try to ask questions that reduces the number of possible models. So the concept of MC still stands, but that's with respect to a set of models instead of one model. Yeah, but that's with respect to uncertainty, whether we know about the human model or not.
So is your question about the uncertainty of the model or uncertainty of the environment?
No, if there's uncertainty in the model itself.
So that's what he's answering.
Yeah, so.
With uncertainty in the environment, it becomes more, well, interesting and complicated. In the sense that, so if you are assuming that the human is an observer, and you assume something, so you assume that the robot will come forward and it went left, that may be because the robot made the decision to go left, or it may be because the environment is stochastic and it wanted to come forward and it went left. And it's not, it's a much difficult problem to ascribe what exactly. Is it an inexplicable behavior because the robot intended it to be, or because it didn't have control over the output? And the explicability question becomes harder to answer.
Other questions?
Yeah.
So in the projection of the planning, you projected the intellect right in like the upper right block.
Mhm.
So how did you choose like which one to project, like green or the red? Like is it something it could have been projected in either of the things, right? Or it depends on the plan that is being generated.
Which example?
The projection of the cross sign over the
blue block? Yeah, so, so the assumption is that we have a mapping between the conditions in the domain and symbols in the mixed reality channel. So if the thing says not available block X, then we have a mapping to what that symbol would be. So if you find from the model reconciliation process that this is the thing that we should communicate, then you find the map symbol and then project that. But the question of what to project comes from the algorithm, and then what's the projection is just a mapping.
Do you have any ideas of how to automate that, or instead of having a designer basically design that
The mapping?
Is there a way maybe to kind of also
So
plan that, learn that?
Right. So I was thinking about this problem that if there is a general set of symbols that the robot has, can it learn the mappings with interactions? That's a problem I'm interested in but haven't solved yet. But it would be the next step, yeah.
No, because there's an entire field of semiotics of kind of how to use what's the meaning of a symbol and so on. And then it seems to be like a very deep theoretical field, but I also I have no idea how it works.
And the problem here is that we can't expect, it's the sample complexity. So we would probably go with an RL kind of setup, and then how many samples can we expect from the human? Right? They can't be saying this symbol means this. So the target is to reach that mapping as fast as possible.
No, but potentially you could also think about maybe there are rules that basically say if you want to convey this, then use a big pattern of this color,
Right.
and red is for
Right.
getting attention and so on.
Yeah.
So all of these.
Those can be used to actually, yeah, definitely. Yeah.
Okay.
Since you opened that kind of worms, I have to say
Uh-oh.
that,
I didn't intend to.
that sooner or later
No,
you're
it's a
going to
good
run
idea.
into the semantic gap. Okay, that is going to be the ultimate, the holy grail, okay, in order to smooth the communication, and you're not really addressing it.
Right. We assume that they have a mutual understanding of what signals mean.
Do you assume the human is rational? Or if the human is not rational, or the human has a wrong expectation because of wrong belief, what will the robot do in this case?
So in most of the examples, I assume that the human is rational, but some of the conclusions do carry over for irrational cases, but not for unsound. So, for example, when we are saying that the plan is the best that the robot could have come up with in the updated model, even if they couldn't have come up with the best plan, they couldn't come up with a better plan, for example, as long as they're not making unsound plans. So, yeah. So in general, we assume rationality, but it can be relaxed in certain cases.
there's another aspect of that, which is just that if you perhaps have a model that the user is slow in some respects, doesn't have all your inferential capabilities, then couldn't your theory of explicability potentially take that into account
Right.
to search for a plan in which the user is going to have an easier time understanding it?
Right. So in the original work on explicability from Tony was based on humans labeling plans and labeling them in the sense they think that they are explicable or not, and that implicitly captures their ability to infer. But the balancing work that I did not have that process. So we have looked at those separately, but not together. But yeah, so if we have the capability to have some idea what the human inferential capability is, that would be taken into account in every node in the model space search. So where we are saying that this criteria is met, that's met given their capabilities. So if you are saying, let's say, the simplest model would be say alpha close to optimality. So then we say the optimality criteria is met with this much percentage. And as long as we are within that region, we say that we are fine. But it might be more complicated setting. So the easiest thing to incorporate would be the percentage optimality or top K optimality.
I'm thinking more along the lines of the depth of inference required, for example, or the certain types of syllogisms might not be possible for the human, in which case their space of plans is different than yours.
Yeah. So when you are making the search, you do not say you can have a fan out of 10 maximum in every state. But those kind of settings would limit the space of plans. Yeah, I haven't looked at that.
I think in a way what he's saying seems to me is the correctness proof, the minimum correctness proof of the plan might require some domain axioms and additional things, and in which case they wouldn't have been able to understand it. And so if you have to make another plan that can be proved to be correct without as much machinery. That's a cute way of thinking about it. He tended to kind of separate inferential aspects from knowledge level aspects, but this does bring some interesting way of connecting, explainability. I mean, the shape of the plan to how hard it would be to prove it. So it's sort of it has to have some connection to the syntactic nature of the plan. Beyond a certain level, however, it becomes hard because in terms of once you start talking about optimality aspects, as to why is this plan better than other plan, that would be interesting discussion. Other questions? Should say any other questions. That's like asking, please don't ask any more questions.
What are your questions?
Okay, so if there are no further questions, then we will complete the open session. Please do eat some more food on your way out, and then we will have the closed session.